2 minutes. Okay. Okay, so let's go to the coding problems. Hey everyone, and welcome to another stream. So yeah, how are you guys doing, and how did you like the problem set? How was the problem set? Were you able to solve all the problems? Did you face any difficulties? So let me know in the chat. Also let me know if you guys can hear me well, or if there's some problem. Hey Vanshu. So how did you like the problems? Were the problems good? Were the problems like, did you face any difficulty with any problem? Anything that you want to tell before we start? Audible. Thanks, Abhishek. So I see the first problem, there are multiple submissions, 1856, that's good. Second problem, 565 of you solved. Third problem, only 272 of you solved. So there's a significant decrease like between first and second. Uh, Anyways, let's get started with the problem statements. So the first problem is Wi-Fi range. What it tells is, let's read the problem statement first. So there are n rooms in a straight line in Geekland State University's hostel. You are given a binary string s of length n, where si is 1 represents that there is Wi-Fi on the ith room, and si equals to 0 represents otherwise. Each Wi-Fi has a range x, that is ith room. If the Wi-Fi is there on the ith room, then it will go x units, x more rooms to the and x more rooms to the right. So you have to find whether all the students in all the rooms can use Wi-Fi, right? So basically what it tells is, it is, you are given a string, right? You are given a string s, and it can be ones and zeros. Like, just assume that there are n rooms, right? There are n rooms in front of you. Now s represents whether the ith room has a Wi-Fi connection or it doesn't have a Wi-Fi connection. Now we know that each router has a range, right? So it is told that if the room has a connection, then it can, like, it will reach, the connection will reach up to x units, x rooms on the left and x rooms on the right? So on the left side it will reach up to x rooms, on the right it will reach up to x rooms. So you have to tell what is the, you're given the set, like you're given the string where the like the Wi-Fi connections are there. You have to tell whether every room gets Wi-Fi or it doesn't get. There is a room that doesn't get. So that's the question. So yeah, would anyone tell how did you solve this? Can anyone tell how did you solve this? It's a pretty simple question actually. Anyone wants to volunteer? How did you solve this? Okay, so question 2 में ambiguity है. Okay, we'll see what is the ambiguity. We'll try to see that. 0 1 0 1. Let's consider some strings, right? 1 0 0 1 0 0 1, and let's say x is 2 in this case, right? Okay, I'll see. Maybe the test cases were not right. I'll see. All right. So x is 2. Again, like what it tells, right? See, in this case, it tells that x is 2, right? So that means if you have a Wi-Fi on this room, it will be reachable to two other rooms on the left and right. On the left, there is no other room. On the right, it will reach two other rooms. So it reaches. Again, there is Wi-Fi here. So on the left, it reaches two other rooms. It will reach these two rooms. On the right also, it reaches two other rooms, and this is the coverage, right? Similarly for this as well, right? So all the rooms are having internet connection. So let's consider x equals to 1, right? In that case, what will happen? X equals to 1. If we see x equals to 1, let's consider this 1 0 0 1 1 0 0 1 0 0 1. So for x equals to 1, from this room will also get internet. So this room gets internet from this room. This room will get internet from this room, because left and right. So this room will also get internet from this room, and this room will get internet from this room, right? So this is also a valid ordering, right, of Wi-Fi. Let's say it is 1 0 0 0 1 0 0 1. In this case, if x equals to 1, it should be false, right? Why should it be false? Because see, for one, from this room, this room will also get connection. This room, for this Wi-Fi, this room will also get connection, but this room doesn't get connection from any Wi-Fi, right? So this room doesn't get connection, so that's why the answer for this, the answer will be false. Okay, I see some approaches that are given there. So setting on a minus x. Okay, all right. Okay, so how would I have done this? Again, how would I have done this? Let's understand this. So if you see, what are we given? We are given a few ranges, right? So we are given a few ranges L comma R, and we have to see if this L comma R, we are given some total range, let's say something, right? Like total, there are n houses, so n, we are given a total range of n, and we are given some ranges, like, right, L comma R. How are we getting the ranges? If you see each Wi-Fi, for each Wi-Fi, the range will be I minus x. Will it be I minus x? I minus 1, yes. I minus x to I plus x, right? I plus x inclusive. So this is a range, right? We are given multiple ranges like this. We have to tell whether there is a full coverage on this n elements, right? So whether there are ranges like this, right? There are ranges like this, multiple ranges. Whether there is a full coverage, right? Full coverage means at least one of the ranges passes through every point. One of the ranges passes through every point. So what would I have done is, again, like whenever we have ranges, what we can do, and we want how many. So basically for each point we want how many ranges are passing through that point, right? How many ranges passing through that point? How many? We want how many ranges passing through that point. How do we count the number of ranges? Whenever it is involving counting the number of ranges passing through a point or something like that, we can use the algorithm that we have discussed before. Like whenever we solve problem like overlapping intervals, or over station problem, like how many minimum platforms are needed or something like that. What was the approach that we used? We used something like, we maintained a table, right? We maintained a table T of R plus 1, so T of L plus plus, and T of R plus 1 minus minus, right? T of L plus plus and T of R plus 1 minus minus. So this is an approach that I've solved multiple times. If you don't know about this approach, you can look up to this, like range update point query. This is called range update point query. Also you can look into the problems such as minimum platforms, right? So there is a problem called minimum platforms. In fact, I believe in last contest as well, we had a problem where it was similar to minimum platforms, where we used this logic that T of L plus plus, so and T of R plus 1 minus minus, and then we found a prefix, take a prefix sum on that, and you get for every point how many intervals are overlapping that point or going through that point, right? So for example, let's consider an example, right? Let's consider the example of this 1 0 0 0 1 0 0 1, and let's say x equals to 1. Okay, so how do we break this down into ranges? How do we break this down into ranges? See, this is 0, right? So 0 will not go to minus 1. So if there is something minus 1, we'll take the minimum, right? So 0 minimum, maximum of 0 comma something minus. So yeah, like it will be 0, right? So it will be 0 comma it is 1, right? So at index 0, so it will be 0 comma 1. This is the range. For this, what is the index? 0 1 2 3 4 5 6 7. So at index 4 there is a Wi-Fi router. So index range will be 4 minus x, that is 4 minus 1, this 3 to 5. 3 to 5 this will cover, and 7 minus 1, so 7 minus 1 is 6. 6 to 7 plus 1, that is 7. Let's will not go beyond 7. So 7 plus 1 will keep it as 7, right? So we'll take this table, right? Initially everything is 0. We'll take this table. So initially everything is 0 0 1 2 3 4 5 6 7 8. So what we'll do, a of 0 plus plus, So 1 plus plus means ones and others will be 0 initially. A of 1 plus 1, that is 2. A of 2 minus minus, or hash map of 2 minus minus. Again 3. A of 3 plus plus. So 3 is 0 right now. 3 will become 1. A of sorry, this is 2 3, yes. A of 5 plus 1 6 minus minus. A of 6 minus minus means 6 will become minus 1. A of 6 plus plus here. A of 6 plus plus, so it is minus 1 right now, so it will become 0. Minus 1 plus 1 is 0. And A of 7 plus 1 8 minus minus, so minus 1. Now let's take prefix sum on this, right? So prefix sum, what it will be? 1, this will become 1, this will become 0, this will become 1, this will be this will become 1 1, oh sorry, 1, this will become 1, this will become 1, this will become 1, this will become 0, right? So if you see, there is a point 2 which does not have any range, and every other point represents how many ranges are passing through that point, right? If you see, every point has only one range passing through it, so that's why the answer will be false here, because there is 2 through which only no range passes, right? No range passes through 2, so the answer will be 0 for this. Okay, so let's try to write the code for this. And there are multiple other ways you can solve this. Like you can use some sorting, you can use hash maps, you can use a lot of the things, right? So there can be multiple ways. You can also use a greedy like approach as well. Like you can have some initial value and you can check always that it never goes down that value or something like that. So there are multiple approaches to this, but yeah, like this is something that I would have done. Because I have because again, like most range problems I would solve like using this approach of L plus plus and R plus 1 minus 1. So let's take the hash map. So int num ranges, let's call it num ranges, and its size will be n plus 1, and initially everything will be 0, right? So initially everything will be 0. So that's there. Now what we'll do is we'll do n plus 1 we have done. Actually we have to do n plus 2 maybe. N minus 1, I think n plus 1 should be fine, like 0 to n. Yep. Now we'll go through all the ranges. So for int I equals to 0, I less than s dot size or s dot length, I plus plus. So int L equals to if s of I equals to 1, definitely. If s of I is equals to 1, then int L equals to I minus x, right? So if L is less than 0, then L is equals to 0. Similarly, int R equals to what? I plus x. If R is greater than n, R equals to n. Then n plus 1, it should be, yeah, R is greater than, so let's make it n plus 2 just to make the calculations cleaner. So num ranges L plus plus, num ranges R plus 1 minus minus, right? Now what we'll do for we'll do a prefix sum. So for int I equals to 0, I less than n, I plus plus, and in fact I equals to 1, we'll start from 1. So num ranges I plus equals to num ranges I minus 1. So we have done the prefix sum. Now for int I equals to 0, I less than n, I plus plus, if num ranges of I is equals to 0, yeah, if num ranges of I equals to or less than equal to, I think it should be always equal to 0, but yeah, less than equal to 0, then return false, otherwise will return true. So that should be the code. Yeah, r greater than n minus 1 should be enough, but yeah, like fine. And this also like should be always equals to 0, not greater than 0. So yeah, this gives 1. Yep, that should be fine. So let's try to submit this. Yep, this is working. So this is how we can, like, this is actually equals to, let's write it equals to 0, right? So this is actually how you would solve the problem, or how you can solve the problem. This is one of the ways. So yeah, definitely try to solve it in different other ways, right? But yeah, like this is this is how I would have solved the problem. So let's go back to the second problem. And this is, I think this is a bit ambiguous to many of you. So let's see if we can try to solve this, right? I'm not sure if the test cases are wrong, but yeah, like we'll try. All right, so let's read the question first. So given a string S which consists of only lowercase English alphabets, you have to perform the below operations. If the string S contains any repeating character, remove the first repeating character and reverse the string, and again perform the above operation on the modified string. Otherwise you stop. Okay, so what it is telling is, if it contains any repeated character, right? If it is containing any repeated character, pick the first repeating character, right? The first character that's repeating, remove it and reverse it, right? And reverse it to and perform the operation once again. And perform the operation once again, and you will stop when you do not have any possible move. You have to find the final string, right? So let's take the example. Take the example. So AB. So AB initially, what are the repeating characters here? A is repeating, B is repeating, right? So first of all, what do? We start like this. AB. What is the first repeating character? A is a character. A is the first character. Is A repeating? Yes, A is repeating, right? So we'll remove A. So we remove A. So what it becomes? BAB. It becomes BAB. Now we reverse BAB. So what is the reverse of BAB? It is a palindrome, so it will be the same. BAB reversing also will remain BAB. Now what is the first character? B. First character will be B. Is B repeating? Yes, B is repeating, right? So we will remove B. So B is removed. What is left? AB. Will reverse AB, so it will become BA, right? And now there is no repeating character, so BA is the final answer, right? BA is the final answer. So D again, like for this it will definitely be D. So that's how you can solve, right? So let's actually understand with another example, right? Let's take another example. So let's say we have something like yeah, A B C B C D B, something like this, right? Okay, what will happen? Sorry, my bad. So what will happen? The first step, what is the first step? What is the first character that is repeating? Is A. A is the first character. Is A repeating? Yes, A is repeating, right? A is repeating. So A, B, C, what we'll do? We'll remove A. So A, B, C, B, C, D, B. Now then what we do? We reverse it, right? So what is the reversal of this? B, D, C, B, C, B, A. So it becomes reversed, right? Now we'll do operation on the reverse string. So what is the first first character? B. Is B repeating? Yes, B is repeating. So we'll remove B. So what it becomes? D, C, B, C, B, A. Reversal of this: A, B, C, B, C, D. Right? So we reverse this. Now, again, what is the first character? A. Is A repeating? A is not repeating here, right? A is not repeating here. We go to the next character, B. Is B repeating? B is repeating, right? So we'll remove B. We'll remove B. So what it becomes? A, C, B, C, D. Reverse this. D, C, B, C, A. You get this. Now, what is the first character here? D. Is D repeating? No. C. Is C repeating? Yes, C is repeating. So what we do? It will become DB, CCA, and you reverse this. So ACCBD. What is the first character that is repeating? A is repeating? No. C is repeating? Yes. So we'll remove C. So A, C, B, D, and we'll reverse this. So it will be D, B, C, A. So the final output should be D, B, C, A, right? The final output should be D, B, C, A. So let's write the. Okay, so let's try to see if this is giving DBCA, right? A B C C. Let's try to do this. A. Let's try to compile test custom input. A. Sorry, I forgot the input. A B C C. A B C C. A B C C. I think there will be another B. C C B C D B. B C D B. So it will be BCDB. Okay, so let's see the expected output. DBCA. Okay, it's coming DBCA, and our output is also DBCA. So this looks good. This example looks good. So how would we do this, right? Let's see if we can get back DBCA. If we can actually get back DBCA, how do we get back, or how do we optimally do this, right? So what we'll do is we will use 2 pointers, right? We'll use 2 pointers because we are reversing, right? Now see, at every iteration we are reversing the string as well and then checking. So whenever there is a reversal involved or something like that, what you can do is you can traverse from both ends, one from the front, one from the back, right? Now whenever there is a reversal, your back pointer will move. If your string is processed forward, your front pointer will move, right? So you can traverse from both the ends, and that will take care of reversal, right? Now one thing we have to check is, one thing we have to note it, that is, if let's say A is a character, right, and A is not repeated, so definitely it will never get removed, so we can safely move to the next character. Similarly, if B is a character at the end and it is never repeated, so we can safely move towards the left for the right pointer, right? So that's one observation, because it is never repeated, right? So it will never get removed after this. So let's start. So we'll have 2 pointers here and here. First is, okay, I'll take that example as well. F equals to 0, right? Initially f equal or some flag, right? Is it reverse or is it reverse or is it straight, right? So f equals to 0 initially. So A is repeated, we'll maintain the frequency of each of them. So frequency of A is 3. So let's write down the frequencies, right? A's frequency is 2, I believe. B's frequency is 2. C's frequency is 3. D's frequency is 1. Sorry, B is 3 times 1, 2, 3. B is also 3. Okay. A has a frequency of greater than 0. So we'll remove this. So A is removed, minus minus. So it will become 1. And we'll move the pointer because this element is removed, and also we'll mark this with some delimiter, right? So we'll mark this with, let's say, $. So this is marked as $. Okay. Next we have a or we can have a boolean array as well that tells that do not take this element. So next we have A, right? And also now if we are processing reverse, because this will be reversed, so f will be 1 right now. Now the first element is B. B is the frequency of B greater than 0? Yes. So B, it will be reduced by 1, 2, and we will make this $. We'll make this $, and we'll go to the front. So to the left by 1 place. So it becomes $, right? Okay. Now D. So again it will be, f will become 0. It will be reversed. So A. Is A repeated? A is not repeated, right? So we can move to the next element B directly. Again B. And will not reverse because we are not doing an operation here. A is not repeated. B. Is B repeated? Yes, B is repeated, right? So we'll reduce 1 and we will make f to be 1 because we have reversed, and and we'll make this $. Okay, plus plus. So it will go here. Now it will become 1, right? So now it will be process reverse. Okay, D. Is D repeated? No, D is not repeated. So we'll go forward. C. Is C repeated? Yes, C is repeated, right? Why we are processing C? Because we are not reversing now, right? We have not done an operation now, so it will be processed backward only. C is repeated, right? So C will reduce it down to 2. We will flip this, so it will become 0, and we'll make this dollar. So we'll make this dollar and our pointer will go front. Okay, right now now it's 0, right? So it will process from the front. C, is C repeated? Yes, C is repeated. It has a frequency of 2, so it will be reduced to 1. This will be made a dollar and will go forward, right? Now it is becoming 1. So B is repeated, B is not repeated, right? B is not repeated. So we have the final string. What is the final string? A, C, and also we have to take it in a reverse way because 1 is there, so it is actually reversed. So the final string will be DBCA. The final string will be DBCA. Okay, and I think that's the answer, DBCA. So the final string should be DBCA. Yes, it should be DBCA. Okay, so let's take the example that Devansh has given us. So DUI if DDAHI. So DUIFDDAHI, right? So we'll start again from left and right. F is 0. We have the frequencies here. Frequency of A is 1. Frequency of D is 1, 2, 3. Frequency of I is 2. Frequency of H is 1. H is 1. D is 3. I, U is 1. I is 2, right? I is 2. So 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, something I've missed. DUI, DD. Okay, D is 3. Yes. AHI. I is 2 times. A is 1 time. F. Okay, I've missed F. F is 1 time. Okay. So let's start. So D, occurrence is 3, so it will be removed. Occurrence is 3, so removed. Make this dollar. Reduce the count to 2. Move that, and F becomes 1. Process backwards. I is repeated. I is repeated 2 times. Yes. So remove this I, dollar. Frequency of I is removed to 1. F will become 0, and this will be decreased by 1. Okay. H. Now 0. So process forward. U has a frequency of 1, so it will go forward. I has a frequency of 1 now, so it will go forward. F has a frequency of 1 now, so it will go forward. D has a frequency of 2, so it will be removed. So D is removed, it will become 1. This will become a dollar. This will become a dollar, and this will become 1, and it's moved forward. And finally we have H. So we have unique characters, right? So the final answer will be HADFIU. HADFIU should be the final answer. So let's see if that's the case. So what was the example again? DUIF DDAHI. DUIF DDAHI, and let's see the expected output. HADFIU. So this is also correct, right? This is also correct. So this seems to be correct to me. Let's write the code and then we'll figure out if something is not working. So S is there, right? S is there, and let's take 2 pointers, right? So int ptr1, or let's call L and R, right? L equals to 0, R equals to S dot size minus 1. Right, and anything else? F is also needed. That will tell like whether it's forward or reverse. So let's make this as is reverse. Is reverse is 0 initially, right? So while, and also we need the frequencies, right? So map char int frequency. So for int I equals to 0, I less than S dot size I plus plus, frequency of int of S of I minus A plus plus. Okay, while L less than R, so what we'll check is if is reverse is equals to 0, then we'll process forward. So process from left, else process from right. So if frequency of int of s of L minus a is greater than 1, if that's the case, then s of L is equals to, we'll replace with dollar, right? S of L is dollar, is reverse XOR equals to 1, we can do, right? XOR equals to 1 is reverse XOR equals to 1, L plus plus, L is done, L plus plus, and also frequency has to be removed, right? So frequency of int of s of L minus a minus L plus plus, right? Else L plus plus. And for right, we'll do the same thing. If frequency of int of s of r minus a is greater than 1, then s of r is equals to, let's say, dollar is reverse XOR equals to 1, frequency of int of s of r minus a minus and r minus else r minus. Okay, so finally we have the string that we generate. So string answer equals to this. So for int I equals to 0, I less than s dot size I plus plus, if answer not equals to dollar, sorry, if s of I not equals to dollar, answer plus equals to s of I, or answer dot pushback will also work, whatever, answer dot pushback s of I. And finally, if is reverse, then we have to return the reversed, reverse answer dot begin, answer dot end, return answer, right? So that's there. You are using map but treating it as an array. Yes, I have just used map because oh, okay, yes, right, I could have just done that. Yeah, like my bad, sorry. Let's do it like this only, in frequency, my bad. I could have just taken the character. So in frequency 26, I'm more habituated with taking it as an array, so I've written it like that. My bad, sorry. So let's compile and run. So A B. Oh, how the output is A? H dot size, if s of I, answer dot pushback. Yes. How is the answer A? It should be A B or B A, right? It should be B A. Okay. It's coming A. For some reason I've written something wrong. Let's check. So frequency is 0 initially. Frequency of s of I minus A plus plus. Then is reverse is 0. Yes, it is 0 initially. So s of L minus a greater than 1. Is it greater than 1? Yes. So s of L equals to dollar is reverse or equals to 1. Frequency of int of s of L minus a. Okay, 1 second. Dollar, is dollar causing a problem? I don't think so. It should cause a problem. It should not. Okay, no. S of L minus a minus L plus plus. Yes. Else L plus plus. Right. Frequency of int of s of r minus a is greater than 1. Yes. Then s of r equals to dollar. Is reverse is XOR equals to 1. Frequency s of r minus a minus. uh, r minus minus else r minus minus. That seems to be okay. Answer is 0, answer I equals to 0, I less than s dot size I plus plus, s of I not equals to dollar, answer dot pushback s of I, reverse answer dot begin. So let's change this from dollar to some other thing like hash or something like that, right? So just so that it's not causing a problem. Yep. And reverse answer dot begin, answer dot end. Does reverse return, or that should be fine. Let's see. It's coming 0. Does reverse, does how does reverse work? Like reverse is, can we return reverse? Let's see if we can return reverse. I think there is some problem with reverse. Does reverse return the string, or it does on the string itself? Yeah, it doesn't return the string. Okay, so it does on the string itself. Answer dot begin, answer dot end, s of I not equals to hash, answer dot pushback s of I. Yes. So print answer. Let's print answer here. So c out answer, sorry, c out s and l. Let's run this. Is reverse or equals to 1 should work. So hash hash a hash. Did we forget to s of r minus 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 a, s of r minus a minus minus, is reverse or equals to 1? That should work fine. That should work fine. I could have done 0 and 1 as well, but that's fine. L plus plus r minus minus. So let's see what happened. So let's add up a few print statement here. So c out L current condition of s, and what does frequency of this thing tells us, right? So that will help us debug faster. So same thing we'll add here. C out R S, and what does frequency of S of R minus A tells us. Okay, so let's copy this and paste, and yeah, sorry, let's run this now. Ones or 1 will be 0, right? 0 first is 0 AB AB, and A has 2. Yes, then it's 3 0 1 2 3. Yes, hash B AB. It's giving a frequency. Oh, okay, endl here is needed, but anyways, 2. Okay, B also has 2. Yes, 1 hash BA hash. Yes. Let's run this. Why is it 2 still? It should be not, it should not be 2. Frequency of int s of r minus a minus minus. I've done this, right? Is it not taking somehow? Okay, 0 ab 2. Yes, 3 ab 2. So B has a frequency of 2. Yes, hash 1, that is index is 1 right now. Yes, B, we are at B, index B. Yes. So its frequency is, somehow its frequency is 2. So this didn't reduce the frequency. F of r minus a didn't reduce the frequency of that. Why is that? S of r minus a is greater than 1. Yes, it enters this thing, it makes it hash. Oh, it is making it hash first. Okay, my bad. So it should be, sorry, I'm actually reducing the frequency of hash, not the actual character. So yeah, silly mistake. Anyways, that's there, and this. Okay, so now it should be fine. BA. Yes. So let's comment these things out, and let's compile and run, and also answer should be commented out here. Oh, sorry, not this one. This should be commented out. and we'll submit this. Okay, now this is working. So let's see the questions reverse. Sorry, my bad. Return function. Instead no, that should be fine. Like ones or one is zero, right? A's or a is zero, so sorting works. Aren't you putting any stopping condition and reversing all available characters? Yes, stopping condition is here, right? Like L less than R. So L less than R will be the stopping condition. I'm allowing it to flow instead. Like there might be a position L and R where we have already obtained all distinct characters, but still like we will at max go up to L. Will just go up to L to R, right? So it will not do anything. It will just go L plus plus and R minus minus. So at every step, either we are doing R minus minus or L plus plus. So we're reducing the space by 1 every time, right? So it will run for n time. So yes, that was the issue. So yeah, like this is the code for this. Okay, so let's go to the last problem. I'm not sure why so less people have solved this. So we have discussed similar things before as well. I'm not sure why so many less people have solved this. But anyways, let's understand the question first. So there is a forest. Okay, there is a forest named Fog. Fog can be represented as a grid of size n cross m, where rows are numbered from 1 to n and the columns are numbered from 1 to m, right? So the rows are numbered 1 to n and the columns are numbered 1 to m. So it's a grid. It's just a grid, right? So let's say R comma C denotes a cell having a row R and a column C, right? So R comma C will denote a row with a cell with row R and column C. You are given k cells where volcano is going to explode. So there are given k cells where volcano starts. In 1 second, lava from one cell moves to all of its 4 adjacent cells, that is R minus 1C, top, bottom, left, right. So R minus 1C, R plus 1C, R C minus 1, R C plus 1. So top, bottom, left, right. So it is said that there are k cells that are given to us from which the lava is starting, the volcano is erupting, and lava will move to the next adjacent cell, that is top, bottom, left, right, in 1 unit of time. We have to compute the minimum time such that the whole forest is on fire or filled with lava, right? The whole forest is filled with lava. So we have to find the minimum number of time. Yes, John, very good. And Sudhavi as well, very good. It's plain BFS, right? It's nothing but plain BFS. So whenever you are asked, right, whenever you are given movement, see, a rule of thumb is that whenever you have a matrix, you are allowed to move in 4 directions or 8 directions, right? And you have to compute shortest path, minimum time, anything like that. Just blindly go with Dijkstra or BFS. If there is a weight involved, go with Dijkstra. If there is no weights involved, if it is 1 unit, like every adjacent cell, just go with BFS. As simple as that. So here we do not have any weights, so that's why we can just directly go with BFS, right? So we can be BFS. But one thing to note here, like you might think, hey, Soham, there are k starting points, right? There are k starting points, and we know BFS is what? BFS is like starting from a given node, you do a BFS, right? So it's a single source shortest path. Or Dijkstra is a single source shortest path, right? So we are given here multiple sources. How can we do BFS or how can we do Dijkstra? That's a very valid question. The answer to this is you will use multi-source BFS or multi-source Dijkstra, right? How do you do multi-source? Just assume that you have a node. Whenever there are multiple sources given to you, right? Whenever there are multiple sources given to you and you have to find the minimum distance. You can use BFS or Dijkstra depending on the weights. If it is weighted, Dijkstra. If it is not weighted, BFS. But if there are multiple sources given, it is a single source, right? If there are multiple sources given, how can you solve it? You can reduce it to a single source problem. How? You will take a dummy node with 0 weight, right? With edge of 0 weight. You will connect it to all the sources. Now this dummy node becomes the starting point, right? This dummy node becomes the starting point, and see, it becomes a single source shortest path. Basically from this dummy node, with 0 weight, you can reach all the source nodes, right? All the starting nodes. So it becomes a single source shortest path. So just to explain this a bit, let's just explain this a bit with some diagram and these things. So let's say we have some graph like this, right? We have some graph like this, beautiful graph. So let's mark the source nodes as cross. This is a source node, this is a source node, this is a source node. How would you compute the minimum distance or minimum time taken to reach each cell from one of these source nodes? How can you do that? You can extend the concept of single source shortest path. How? You create a new node which has a zero edge weight and connect it with all three of them, all the three sources. Now if you do a single source shortest path algorithm, it is becoming the same as starting from this, because from here to here it takes zero edge weight, right? So instead of actually creating the dummy node, what you do is, in your whatever you're using for your Dijkstra or your BFS, for BFS what do we use? We use a queue, right? We use a queue. What for Dijkstra, what do we use? We use a set or a priority queue, right? Whatever we are using in a multi-source problem, just insert all the initial nodes in the queue or insert all the initial nodes in the set and then start doing your Dijkstra. This, you will get the answer, you will get the same answer that is expected. सर थोड़ा हिंदी में बोल दिए, ठीक है हिंदी में बोल देते। तो अगर तुम्हारा क्वेश्चन ऐसा रहा, राइट, अगर तुम्हारा क्वेश्चन ऐसा रहा कि यू आर गिवन अ ग्राफ, तुमको एक वेटेड ग्राफ दिया है, यू हैव टू फाइंड द शॉर्टेस्ट डिस्टेंस, और या तो तुमको फाइंड करना है मिनिमम टाइम, ऐसे टाइप्स का क्वेश्चन, जो शॉर्टेस्ट डिस्टेंस टाइप का क्वेश्चन है, ऐसा कुछ फाइंड करना है। बट प्रॉब्लम ये है कि तुमको मल्टीपल सोर्सेस दिया है, यू आर गिवन मल्टीपल सोर्सेस। सो तुमको ऑलरेडी एल्गोरिथम्स का पता है, बीएफएस, देयर इज बीएफएस एंड डायक्स्ट्रा, बीएफएस और डायक्स्ट्रा पता है, जो सिंगल सोर्स शॉर्टेस्ट पाथ होता है, सिंगल सोर्स शॉर्टेस्ट पाथ। We can reduce this single source shortest path to multiple sources as well. कैसे करेंगे? एक डमी नोड इंट्रोड्यूस कर लो, ये ग्राफ में एक डमी नोड इंट्रोड्यूस कर लो, मान लो इसको डमी कहते हैं, राइट। कनेक्ट ऑल द सोर्स नोड्स विथ दिस डमी नोड विथ द वेट ऑफ जीरो वेट के साथ, जीरो एज वेट के साथ, इस डमी नोड के साथ सारा सोर्स नोड्स को कनेक्ट कर लो, ओनली सोर्स नोड, नो अदर नोड। इससे तुम्हारा, अगर तुम अभी इधर से डायक्स्ट्रा या बीएफएस स्टार्ट करोगे, दिस इज योर सोर्स नोड, अगर तुम इधर से स्टार्ट करोगे, देखो तुमको हर नोड का मिनिमम टाइम या शॉर्टेस्ट डिस्टेंस मिल जाएगा फ्रॉम अ स्टार्टिंग नोड, राइट। क्योंकि इधर से तुम इधर जीरो वेट में जा सकते हो, इधर से इधर जीरो वेट में जा सकते हो, इधर से इधर जीरो वेट में जा सकते हो। तो इंस्टेड ऑफ, तो और एक चीज कर सकते हो, इंस्टेड ऑफ एक्चुअली क्रिएटिंग द डमी नोड, तुम डायरेक्टली क्यू पे सारा स्टार्टिंग नोड्स पुश कर दो। जब तुम स्टार्ट कर रहे हो बीएफएस, क्यू में सारा स्टार्टिंग नोड्स पुश कर दो, तुम बस सोर्स को पुश करते हो, उसकी जगह सारे सोर्सेस को पुश कर दो। डायक्स्ट्रा कर रहे हो तो सेट या प्रायोरिटी क्यू में सारे सोर्सेस को पुश कर दो, सेम चीज बन जाएगा। ठीक है, हिंदी में समझा दिया, आई हैव एक्सप्लेन्ड इन इंग्लिश, आई हैव एक्सप्लेन्ड इन हिंदी, देयर शुड बी नो डाउट ऑन दिस, राइट। सिंपल कंसेप्ट, इफ देयर आर मल्टीपल सोर्सेस गिवन टू यू, जस्ट push all the sources into the queue or into the set or priority queue before the start of the algorithm. In this traditional algorithm, you push only the source node, right? Instead of that, push all the sources. Simple concept. All right. So again, whenever you are given a matrix, first is whenever you are given a matrix and you are allowed to move in 4 directions, top, down, left, right, या 8 directions, top down left right, 4 directions mean top down left right, diagonal like diagonal up, diagonal down, those are different thing, right? They might be solved with DP as well, but top down left right or 8 directions, just simply go with graph algorithms. If it's the shortest path or minimum time, go with BFS shortest path algorithms, BFS, Dijkstra, these things, right? In BFS or Dijkstra, if there are multiple, these are single source shortest path, right? These are single source shortest path, SSSP. If there are multiple sources given to you, multi-source, what you do is push all the sources, like push all the sources in the queue or priority queue or the set or the queue. Okay, so that's the concept. Simple. We'll do this. Not explaining much. We'll directly go into the code for this. Right. We'll directly go into the code for this. Pretty simple. Volcano is given to us. What? How are the sources given? Let me see. 2 1. Volcano is given at time 0. Okay, this is given as r comma c. Okay, r comma c is given to us. Okay, that's fine. R comma c is given to us. So we'll create a distance time matrix, right? Time matrix, mean time. Let's call it mean time. Nm, right? And for also, I'm assuming it is 0 1 based indexing. Not sure. No, I think it is 1 based indexing. Yes, it's 1 based indexing. So mean time n plus 1 m plus 1. For int I equals to 0, I equals to 0, I less than equal to n, I plus plus. For int j equals to 0, j less than equal to m, j plus plus. Mean time ij equals to, let's say, int max initially. Okay, and yeah, that should be fine. So mean time ij is int max. So first is we have all the sources with us, so we'll take a queue of pair, right? Pair intent. Yeah, I think pair intent, yes, that's fair. Queue. So queue for vector int cell belongs to volcano. For vector int cell belongs to volcano, what we'll do, q dot push, q dot insert, I think q dot insert, yeah, q dot push, q dot pop, q dot pop. Okay, q dot push, let's assume push pop. So q dot push cell of 0, row and column, cell of 1. Let's push the cells, right? So while not q dot empty, int tp equals to q dot front. So not int, it's a pair intent. Pair intent, let's call it not tp, but let's call it a cell, right? Q dot pop, and so the for so the is valid. Let's make a method. Let's all right. So bool is valid int row, int column, int n, int m. So if int m, yep, if row is less than equal to 0, or column is less than equal to 0, or row is greater than n, or column is greater than m, will return false. Otherwise return true. Like this cell is a valid cell, right? So q dot pop. Okay, now okay, int row, let's write down row here. Row equals to cell 0 minus cell 0, and int column is cell 1, and dx dy, let's write down the dx dy's as well. So vector int dx is equals to 0 1 0 minus 1, and vector int, so basically dx dy is for traveling in 4 directions. I hope that you already like use something, or you can manually write the conditions as well, right? Row minus 1, row plus 1, column minus 1, column plus 1. So 1 0 minus 1 0. Okay, 1 0 minus 1 0. So for int I equals to 0, I less than 4, I plus plus, int next row equals to row plus dxi, in next column is equals to column plus dyi. If is valid what? Next row, next column, n comma m, and what? Min time next row, or rather we can check and yes, min time next row, next column is equals to int max. Like it is not visited yet, so what we'll do visit it. So q dot push next row, next column, min time next row, next column is equals to min time row column plus 1. Also initially we have to set the min time of all these row columns to be 0. So min time of cell 0, cell 1 is equals to 0, right? So finally, what is the minimum time for all of the entire forest? So we want the maximum value out of this. So in maxval is equals to 0, for int I equals to 0, I less than n, I plus plus, for int, or rather 1, I equals to 1, I less than equal to n, I plus plus, for int j equals to 1, j less than equal to m, j plus plus, maxval equals to max of maxval and min time ij, right? So that should be the max, and finally return the maxval, return maxval. So that should be it, right? That should be it. So let's try to compile and run and see if this is working at all. Okay, pair intent. Okay, where is a pair? Oh, cell dot first, cell dot second, sorry, cell dot first, cell dot second. So let's compile and run. This is giving 2. Not sure if the answer should be 2. Answer should be 2. Okay, so let's submit this. So this is also working. All right, so yep, we have done DFS for this. Pretty simple question, like straightforward DFS. Only catch was multiple sources. That's also like sorry, we have done BFS for this, so multiple sources also we can do BFS or Dijkstra. So that's all the questions for today. Yep, any doubts that you have? Otherwise we can call it a day. Anyone has any doubts? Thanks, Shrobi. All right, if no one has any doubts, let's call it a day. Thank you guys for joining in, and yeah, I'll be seeing you next Sunday. Bye.